welcome back. Yeah, so we're talking about memory leaks and dangling pointers. And so the idea with with the memory leak is that you just simply never delete, right, the data that you allocated with new. So if we're thinking about like the end of the program, you think about the end of the program, and now maybe the array objects were not dynamically allocated. Those are just allocated statically. So maybe we get to a point like this, but if we forgot to do the delete statement in the destructor, right, then those two arrays of integers would still be on the heap, right? So that'd be an example of a memory leak. Then example of dangling pointer, right, would be you did delete them, but you still left the pointers pointing at those same locations on the heap. So you did delete this array of integers, you deleted this array of integers, but then, we still left the pointers, right, pointing at them. So that'd be an example of a dangling pointer. So that's the idea, again, of the two problems. We saw that you could avoid both, though, by just doing the delete bracket. And it's the bracket, right? So there's the version of new that doesn't have the brackets, right? Like if you're just dynamically allocating a single object, then you could do, like, for example, new array, and then the corresponding, or array star PTR equals new array parentheses 2, for example, if you want the array of integers to be 2, and then the corresponding delete, right, would just be delete PTR without the brackets. But if you're using the array version of new, then you should always use the array version of delete. Or if you're using the non-array version of new, then you should use the non-array version delete, right? Otherwise, you can start running into undefined behavior and problems. So the way you use delete, right, should match up with the way that you use delete. So we saw that you could avoid both problems by doing the delete first, and then if needed, set the pointer to null PTR right after it. Then you can avoid both problems. All right, so any questions on any of that? Okay. Okay, so now we'll talk about inheritance, and we previously talked about composition, which we called a has a relationship, such as a deck of cards has multiple cards, right? Which is why you had in that assignment a vector of card objects. But inheritance is another type of relationship that we can have between classes, right? So composition has a relationship, meaning we can use the name of the two classes in a sentence with the phrase has a, and it's going to make sense, right? And inheritance is what we call a is a relationship. So we can use the name of the two classes in a phrase with the word or words is a, and it's going to make sense. So, right, it's a different kind of relationship compared to composition. So you always want to think about the natural relationships that can exist between your classes, and you want to distinguish between things like has a or is a relationship. And so the idea though with inheritance, we call it a is a relationship, such as a student, talk about like a student and a person, right? You would say a student is a person, not a student has a person or a person has a student or something like that. But what it's also going to mean in terms of code, right, is that you're going to inherit, which is where the name comes from, things from the parent class into the child class. So, and we'll look at an example that's going to involve two different types of employees. One is called a commission employee. The other is called a base plus commission employee. And so the idea is that the base plus commission employee, in terms of what it should have, it's going to have the same variables that this commission employee class has, but it's going to build on top of that, right? And that's kind of the general way that inheritance typically works, right? You can have a parent class and a child class. The child class inherits. We'll talk as we go through this about what's inherited versus what's not inherited, but inherits most of the parent class, but then can build on top of that. And because one of the things that also happens as a result of doing this is we avoid repeating code. Because when we think about the two classes together and how we want both of them to work, with that base plus commission employee class, it's going to have, right, the member variables and the same member functions as its parent class, which is called commission employee. So we'll see that the commission employee class has things like a first name field, field for the first name, field for last name, field for social security, gross sales, and commission rate. And so the idea is that if you're a commission employee, then you're paid strictly on commission, right? There's no salary, right? No annual salary or anything like that, right? You strictly make money based on your sales that you make, right? So you make a cut or a percentage of that. A base plus commission employee also has a commission rate. So meaning for every sale they make, right, they get a cut or a commission. But on top of that, they have a base salary, right? So they have, two sources of income. And so without inheritance, and this is one of the first examples from the chapter 11 in the book, without inheritance, what ends up happening is when you implement that base plus commission employee class, you end up duplicating, right, essentially everything from the commission employee class, because we still want to have the same fields, like meaning the fields that the commission employee class has, we still want to have those same fields, such as the first name, last name, social security, gross sales, and then the commission rate, and the corresponding member functions that work with those variables, right? We want to have all that in both classes. So without inheritance, meaning if we don't take advantage of the natural inheritance relationship that exists between these two classes, then we end up duplicating in essentially everything from the commission employee class to the base plus commission employee class, which is not good, right? We should be not making a habit of duplicating, large blocks of code. So with inheritance, we can avoid all that by just directly having the base plus commission employee class inherit the members of the commission employee class. So that way we do, inside of the base plus commission employee class, we don't have to write out things like the variable declaration for first name or for gross sales or for commission rate, because those are all going to be brought in from the commission employee class. So really the only, the things that we do have to declare is things like, for example, constructor, right? Because constructing a base plus commission employee object is different than constructing a commission employee object, because it is going to have a extra member variable that the commission employee class is not going to have, right? Going back to the idea of having two sources of income, which a commission employee does not have. So we're still going to write out, things like constructor, um, destructor if we want to do that, like especially if there's going to be like dynamic memory and allocation. Um, but when you think about a lot of the functions that are going to be present in the commission employee class, like get first name or get last name, get gross sales, get commission rate, right? We don't have to redefine all of those functions in the base plus commission employee class. Now we'll eventually see that it is possible to have a function in the base class, which or parent class, which would be the CE or commission employee class, and redefine it again in the child class, which would be the base plus commission employee class, because you could redefine it to work a different way. But unless you need it to work differently, the idea is we don't have to always do that, and we can instead just use the version that's coming from the parent class. And so in this base plus commission employee class, we're going to write out things like a constructor, and then for that new member variable, which is for the base salary, we'll still have to do the functions to work with that, like a get base salary type function. But beyond that, we don't have to duplicate everything that's in the commission employee class. So as a result of doing that, we're able to significantly reduce the amount of code, right? Because without inheritance, we'd have to duplicate almost everything, right, from the parent class and the child class. But one of the major benefits is that we don't have to do that. So the child class or the base plus commission employee class, it's still going to have some things we need to do directly in that class, like the constructor is one example. There'll be some set get functions and a couple other things, but it's a lot more concise compared to than if we didn't use if we didn't use inheritance at all. But we need to think also about that idea of the phrase is a. What does it really mean to say that in this case a base plus commission employee is a commission employee? Well, we have an idea of what that means in terms of English, but right, we also need to think in terms of what that means code-wise, in terms of the classes, right? So when we think about the object in memory, meaning the base plus commission employee object, it really has two parts to it: the base plus commission employee part and the commission employee part. And so one thing that we'll see along the way here as well is that's a key thing that we have to also think about here and take into account. Because when you're creating a base plus commission employee object, right, you have to think about, well, how are you going to create the commission employee, meaning the parent class part of the object? And we'll eventually see how this idea works and how this idea scales when you also have more than two levels in your inheritance hierarchy. Because we'll eventually look at a project that has 3 levels of inheritance, and we'll see that it's the same general idea. But when we say that one class is another class, in this case, a base plus commission employee is a commission employee, we mean just that, right? So when we think about the object in memory, and you think about the number of variables, so the idea is that in the base plus commission employee class, the only member variable that we define directly there is for base salary, because that's the one thing that a base plus commission employee has that a commission employee does not have. Everything else is coming from the other class, right? The parent class or the commission employee class. But when you think about the object in memory, meaning when you create that child base plus commission employee object, it has both parts to it. So that means we have to also create both parts correctly, and we have to also destroy both parts of the object correctly as well. And so one thing that we'll also see here is that when you're creating a child class object, meaning in this case, base plus convention employee object, in its constructor, right, it has to call one of the constructors from its parent class, meaning from the commission employee class, meaning in the member initializer list. So we saw before the idea of delegating constructors, right? Constructor calls another constructor in the same class. Well, now we're talking about calling a constructor in another class, in particular in the parent class, because that's the very first thing that has to happen, right? When you create a base plus commission employee object, you're going to create the commission employee part of the object first, meaning the parent part of the object first. So the base plus commission employee constructor is going to call one of the commission employee constructors. That's going to initialize, right, the commission employee part of the object. And then when that constructor returns, then you'll continue initializing the child object, meaning the base plus commission employee object. So that's another key thing that we'll see come up here as well. But that's kind of the high level idea. And we'll start here with an example where there's just two levels, right? So two classes and two levels of inheritance. A student is a person, but then we'll look at this example with the two different types of employees. So we're going to have these 5 fields in the commission employee class. And again, they only are going to have one source of income. And so this is going to be the parent class, right, or the top class in the hierarchy of these two classes. And the child class is the one that we call base plus commission employee, or BPCE for short. This is what we would call, and there's different terms that we used in general with inheritance. So parent and child, is one way that we distinguish between the two classes. Um, another term that comes up are base class versus derived class. Where here, I mean, we could use those terms as well. We just want to keep in mind that so the top level class is what we would call the base class or the parent class. And then the lower level class here, the BPC class, is what we would call the child class or the derived class. So, that's why it's maybe a little bit more convenient here to use parent and child, just because we want to keep in mind that when we talk about base class, that would actually mean the CE class, right? Not the one that happens to be called BPCE or base plus commission employee. So those are just different ways we refer to the different classes in the hierarchy. Right, and then you can imagine how it extends from this to further levels, because you could also talk about a grandparent class or a great grandparent class or a grandchild class, and so on and so forth. Right, if you have more than two levels in your inheritance hierarchy. So the idea is that we, in terms of member variables for the BPCE class, the child class, there's only one that we need to define directly, which is the base salary, because that's not coming from the CE class. But everything else is from the CE class. And then there's also going to be, as we'll see, a few other functions, because you're going to have things like your usual set and get and all that, plus a couple of other extra functions as well. But the idea really is that in this example, the child class, meaning the BPCE class, it can use in these fields the same way that the CE class does. So things like, dealing with the first name, dealing with the last name. Because remember, what's going to happen when we create the child class object, meaning the BPCE object, the very, very first thing that always has to happen is we have to call the constructor from the CE class. And that's going to handle initializing things like the first name, last name, social, gross sales, right, commission rate. And then from there, then we can come back to where we left off in the BPCE constructor and initialize the base salary, right? The one member variable that was defined directly as a new thing inside of the BPCE class. So that's the idea in terms of initialization. And so we don't really need to redefine things like, for example, get first name, right, from the CE class, because that's going to work the same way in the BPC class, right? There's no difference. Or setting a first name, setting a social security right. None of those things would need to work differently in the BPCE class compared to the CE class. Now, eventually, we'll talk about things like, especially when we get into the polymorphism and all that, we'll look at things where you might take a function that was defined at the top level, the parent level, and then make it work a different way at the child class level. But that doesn't really come up here. with things like set first name or set social, set commission rate, get commission rate. Those all work the same with both classes. So we don't need to really redefine anything, but we do need to handle the new member variable base salary, because that's the one new member variable that that comes up here. So we're going to be inheriting the variables and the corresponding member functions from the CE class, and then they're going to be part of the BPC class. Now, one thing that doesn't happen by default, right, is like we don't, for example, inherit things like constructors or the assignment operator or destructors. We'll see later that there is a way that you can inherit a constructor, but that's kind of a specific situation that has situational use. But what we are going to inherit are all the regular member functions, if you want to call them that, like the set functions, get functions, and whatever else in terms of non-constructors, non-assignment operators, non-destructors. Those are all going to be inherited into the child class. Now, so everything's going to be inherited, but one thing we have to think about is what are we allowed to do versus not allowed to do in the BPCE class in terms of things that are coming from the CE class. So, for example, in the BPCE class, can we access the first name field like how you would do in a friend function, for example? Well, the answer there depends, right, on how things are being set up. Because even in the context of inheritance, you still want to think about things like encapsulation. So there is another access specifier called protected that we have available in addition to private and public. And the idea with protected is if you take a variable and you declare it with the access specifier protected instead of private, then when you establish an inheritance relationship, the child class will be able to directly access the protected members of the base class. So meaning if we go into the CE parent class and we make these 5 variables all protected, then when we're writing out our functions in the child class, meaning the BPCE class, we would be able to directly access, for example, first name, right? Or last name or the social security. We'd be able to, in other words, inside the child class, we would be able to access those members without having to go through a public function. But what if we make the variables private? Are we still going to be able to do that? And the answer is no. So even though we have this inheritance relationship, right, we know that there's very strict rules with the access specifiers going back to encapsulation. And so because we don't necessarily always want to just give the child class direct access to all of the base classes, for example, variables, member variables. It's possible to do that, right? Because you can make them all protected, but it doesn't necessarily mean that you're going to always want to do that, right? For the same reason that you wouldn't in general do that, with the application program, right? Because we know that whenever you start doing things like that, if there's input validation that's taking place in the function that you would normally have to call, meaning things like a set function or other functions that maybe change the value. And you're obviously able to bypass that if you're not having to call the function in the first place. Well, in the same way that we don't want the application program to be able to bypass things like the input validation that's taking place inside the, for example, set function. You want to think about those issues in terms of the child class and the parent class, right? Because if you do that, if you make them protected, then the child class is going to be able to directly access those members. And then if there's any sort of input validation that you would normally go through, well, then you're not going to be going through that, right? So that's why we can still think about those issues even when we're setting up an inheritance relationship. So one way of handling this would be protected, right? I mean, um, we can situationally think about whether it's going to cause problems or not based on the nature of the two classes. But the other approach would be just to keep the variables private, and then that would force the child class to still call the member functions to access data from the parent class, similar to how the application program itself always has to do that. So those are things that we can think about as well. But that's what the access specifier protected will do if you do end up using it, is it's going to allow, meaning if we go into the parent class, the CE class, and we declare all 5 of these under protected, that just means that in the child class, we're going to be able to access those directly without having to go through any sort of public function. So that's the implication of what protected is going to do. That's why we have protected there. It's just something that really was designed for an inheritance in particular. If we do want to have that kind of access be allowed, right, where we do want the child class to be able to directly access the base class's members. Um, and then we also said that in terms of this is a relationship, right? The big idea here also was that when you think about the child class object, is it really has, in this case, it really has two parts, the parent class part and then the child class part itself. So that's how we always want to think about this, right, in terms of memory. And again, it applies in the same way also when you have more, um, more than two levels in your inheritance hierarchy. But for now, we're just looking at two levels. So the BPCE object has two different parts, and we're also seeing here the idea in terms of when the two parts are created or destroyed, because the first thing is that you actually create the parent part first, the CE part of the object first, then you create the BPC part of the object, and then they're destroyed in the reverse order. So the child class part is destroyed first, and then the parent class is destroyed second. But that's how we think about a BPC object in terms of memory, right? Because that's really what we mean by this idea of is a. So it always has both parts, and we need to think of them as really equal parts, right, of the object, right? So the CE part of the object is just as important as the BPCE part itself. And that's going back to why we said that it was so critical that in terms of the child class constructor, that the very first thing that you're doing is calling the the base class constructor, because that's the very first thing that always has to happen here. And now, in terms of the actual syntax for physically setting up the actual inheritance relationship, there's really one specific thing that we have to do. So a couple of things is that we're going to see that the child class header file is going to need to include the parent class header file. So the BPCE is going to need to include the CE class header file. And then the other thing is we set up the actual inheritance relationship, right? on the same line where we write out the class, right? So this is something that we write out in the header file. And what it's going to look like is, so we have the whole class and then the name of the class. And then after that, we have a colon. And then after the colon, what we're going to do is we're going to refer to the parent class, the CE class by name, and we're also going to indicate the type of inheritance. And for now, we're just looking at what's called the most common case of inheritance, which is what's called public inheritance. So you can do public, protected, or private inheritance. But the idea with public inheritance is that when you inherit something from the base class down into, or from the parent class down to the child class, it never becomes more restrictive in the child class compared to how it was, in the base class. Whereas with the other types of inheritance, which are not nearly as common, you have things that become more restrictive in the child class compared to how they were originally declared in the parent class, which is not something that we necessarily want to do on a regular basis. So what it means is that if you have something that's public in the parent class, it's still going to be public access in the child class when you inherit and bring it down from the parent class down in the child class. It's still going to be public. And it also means that if you have something that is protected access in the parent class, it's still going to be protected access in the child class when you bring it down. If you have something that's private in the parent class, we would say that it's actually hidden or inaccessible in the child class. The idea being that anything that's private in the parent class, right, is not going to be directly accessible in the child class, similar to how it's not accessible in the application program. So going back to what we said earlier about protected, that's why we also have that keyword protected. So if we do want the child class to, the BPC class to be able to access things like the first name or the salary, gross salary directly, then we can make that protected. But if we make it private in the parent class, then we're simply not going to be able to do that directly. So the child class. So that's why public inheritance is so common, though, is because it does not make anything more restrictive in the child class compared to how it was in the base class, which is in many cases what we want. So what's going to happen is on the line where we declare the class, we're going to put the word public in the declaration as well. And that's what physically sets up the actual inheritance relationship, right? Is really that one extra thing that we'll put in the class declaration. So public members in the parent class are still going to be public in the child class. Similar idea with anything that's protected. And then private members in the parent class are always going to be inaccessible no matter what. No matter what type of inheritance, are going to be inaccessible in the child class. But in particular with the protected and the public, right, we're keeping them with the same type of access across both classes if we do public inheritance. Okay, but what the declaration is going to look like is this. So meaning for the child class, that's where when we declare the child class in that header file is where we actually officially set up the inheritance relationship. And so what it's going to look like, and we're just abbreviating here, but it's going to be class, and then the name of the class is base plus commission employee, and we're just abbreviating here. So class BPCE, public CE, and then the curly brackets with the rest of the full class header. But that is what actually establishes the physical inheritance relationship between these two classes. So class, the word class, the name of the class, but then after the colon, we're going to have the word public, and then after public will be the name of the parent class, which is the commission employee or CE class for short. So that's how we physically set up the inheritance relationship between these two classes. Yes. Parent and base, yes, so those are interchangeable. And derived and child are interchangeable. Yes, those are just different ways of referring to those, yeah, different classes in your inheritance hierarchy. So publicly inheriting from the CE class. So that's what makes it official, right? And then the other thing is that we're also, because since we're going to be referring to things, right, at some point we're going to need to refer to things from the CE class inside of the BPC class. So that in the header file for BPCE, we need to include the header file for CE. That's the other thing that we need here as well. So in terms of actually physically setting up the inheritance, this one extra thing here is doing that. So that's all it takes to actually set up the actual relationship. And now we can look at these two classes and how they're going to ultimately work together. And again, you know, this is an alternative to simply duplicating the code from the CE class to the BPC class, right? That would be the alternative approach where we don't use inheritance. But that's really something we want to avoid, right? Is having to duplicate, large amounts of code, and we're doing just that um, by setting this up as an inheritance relationship. Okay, so we'll look at first version of this. Starting from the top, and then we'll look at the next class. So this is the parent class, the commission employee. And I mean, since this is the parent class, it's not going to be referring to anything in the base class. So when we talk about the is a relationship, right, that goes in one direction. So for example, when you talk about a commission employee object in memory, it only has one part, right, the commission employee object itself. Whereas the child class has everything from its parent class plus more in general. So we have the 5 variables down here, and with this version, they're protected. So the child class, the BPC class, is going to be able to access any of these directly. And then these are the functions that we have also. So we have a constructor that takes in arguments for all of the variables. We have the usual set of set and get functions for each of those 5 variables. And we also have a couple of extra functions. This earnings and toString. And we'll see those functions show up also in the child class. Because this is an example of where we want to have a function with the same name, right, in the child class. But the way that it works, at least with these 2 functions, is going to be different in the child class compared to the parent class. Because, for example, the way that we calculate earnings, well, that's a different calculation for a base plus commission employee versus somebody who's just a commission employee, right? We calculate that differently. And also toString, the idea with toString is this can be used to output, it returns a string object, but it can be used to help output everything about the employee that we're dealing with. And that also will need to work differently in the child class because we have that extra field for the base salary. Whereas the other functions, meaning the block of set and get functions, nothing at all would be different from those compared to the child class. So we don't need to redefine any of those functions in the child class, but we do need to redefine these ones in the child class because they're going to have a different implementation. But this is the header file for the top level, the commission employee. And then we'll go through this quickly here, because the major focus is going to be on the child class. That's where we really start to see how the inheritance is working. But here we have the constructor for the commission employee. And so this just initializes all 5 of the fields with the values that are passed in. We have things like our set first name to initialize first name, and then get first name, and so forth. So just initializing all of those fields. And then gross sales has a little bit of input validation, checking if the sales that we passed in is a negative number. And so on. But the 2 that are going to be different, right, in particular are going to be these 2. These are going to both be a little bit different in the other class, right, the child class. Because here we can see that earnings at the top level class, the CE class, well, what it does is it multiplies the commission rate times the sales, right? So they made a certain amount of money in sales and they get a cut of that, they get a commission rate. Whereas in the other class, you would also be adding the person's base salary as well to calculate their earnings. So that's why we need to actually have a new version of that exists in the base plus commission employee class. Because if we just simply have the base plus commission employee use this version, then we would in effect be saying that even a base plus commission employee, their income only comes from their sales, right? Or a commission of their sales, which is not really accurate. So we're going to redefine that in the other class. And likewise here with this toString function, you'll see here that we're referring to each of the 5 fields because this is building a string that we can use to display all this information in the application program, right? So we can see it on the console screen. But the toString here at the top level class, the CE class, shows the first name, last name, social, gross sales, commission rate. But what it's not showing is the base salary. So that's also why we need to redefine toString also in the child class. Because in addition to these 5, it's going to need to also show the person's base salary. So that's the parent class, the top level class. But now let's look at the major focus, which is the child class and how the inheritance is being set up and managed here. So now we go into the base plus commission employee header file. First thing here, like we had in the Word document, that is setting up the actual inheritance relationship between these 2 classes. So we have after the name of the class, right, we have the colon and then public commission employee. And we only have to have a few things, right, in terms of the functions and variables here, since we're taking advantage of the inheritance. So the things that we define directly within the BPCE class is the constructor. And notice the number of arguments that we have here. We only define one variable directly in the BPCE class because of the inheritance, but you still have to think about what about the things that are coming from the CE class? Because those are also part, right, of the base plus commission employee object. So that should still be reflected in things like your constructor. So the idea is that we have, in terms of what we're passing here, we're passing in 6 things. Arguments for the 5 fields that are coming from the CE class, plus also a value for the base salary. Because we have to think about initializing all of that. And what's going to happen when we look at the constructor is it's going to be calling the CE class constructor. So we'll see that in a moment, but that's why we have a total of 6 fields here in the constructor. And then we need to have a set base salary, get base salary. Those are new functions, right, that were not in the parent class. And we're redefining earnings and toString because those 2 functions are going to have a different implementation compared to how they worked in the parent class. But notice that we're not, all those other functions, like the, set first name, get first name, set last, get last, all those other functions, we're not redefining those functions in the child class or the BPCE class, because there'd be no benefit to doing that, right? Because the implementation is still the same, so there's no point really in redefining it. The only ones where we did need to redefine it were earnings and toString, because those do have to have a different implementation in the child class compared to the parent class. And so we have a much shorter implementation here compared to than if we didn't use inheritance. So earnings and toString, those are the only ones that we need to redefine. And then everything else here are new things that we're declaring for the first time in the BPC class, like the set base and get base. And then as we mentioned in the Word document, the constructor here has to initialize the CE part of the object as well, which is why we have those fields being passed in. So now let's look at the, and then the other thing here is, as we mentioned, we have to include the header file for the commission employee class. But let's go ahead and look at the CPP file or the implementation. And so here's what that constructor looks like. So we have our 6 fields here, but notice what's happening on the member initializer list. This is the very first thing that we do before anything else. Whenever we create a base plus commission employee object, very first thing is we call the commission employee object. So we have 6 arguments passed to this constructor, but really the first 5 of these are corresponding to the 5 member variables from the CE class, right? And those 5 are all being passed to the commission employee constructor. So that's how we handle initializing that part of the object, right? So the very first thing we do is we call the commission employee constructor, and we pass in the first 5 parameters that were passed to this constructor, and then that constructor runs, and as we saw before, that one just sets all 5 of the member variables. So that's the very first thing that's going to happen before anything else whenever we are creating a child class object, in this case a base plus commission employee object. That's the very first thing. So the idea is we do a function call then, similar to delegating constructors, but now we're calling a constructor in another class, but in particular the parent class. So we temporarily leave the base plus commission employee constructor, call the commission employee constructor, initialize that part of the object. Then we come back to where we left off in the base plus commission employee constructor, and then we initialize the salary field, right, which was the new field that was declared for the first time in BPCE that does not occur in the parent class. So after we come back from finishing the call to the commission employee constructor, we turn around and we call set base salary to initialize the salary. And then when that's done, now we've initialized everything related to the base plus commission employee object. So that's the first thing that happens. And that's why it was so critical that, that we be able to pass in fields for the CE object part as well. So this way, when you think about the application program, regardless of what type of object you're working with, right? Because, throughout the application program, we might certainly want to create both types of objects, right? We might want to do things like create commission employee objects and, be able to set things like their name and their commission rate and all that. But at the same time, when we're creating a new base plus commission employee object, we want to be able to set those things as well. So that's why it's important that we're able to pass in those values to this constructor. So that way we can still initialize, even when we're dealing with a child class object, a BPCE object, we still have that control as far as initializing things like what's the sales going to be, or what's their commission rate going to be, or what's their first name going to be. Well, we still have control over that because we can pass in all of those. And then we saw that we just turn around and pass all of them to the commission employee. So it starts with creating a base plus commission employee object in the application program. And since this is the only constructor, right? We're going to have to pass, we're going to be passing in the 6 arguments, but then we turn around and then just pass them to the commission employee constructor, which handles that part of it. And then we come back and initialize the base salary. So that's the idea. And now we have things like our set base salary, get base salary, just kind of standard implementation for those. Now, we'll in general see different ways when we look at the other version of this, different ways that we could potentially implement things like earnings. At the moment, we do have access to the protected members of the parent class. This is what's happening here. So what this is doing then is we're just saying base salary, which is locally defined directly within BPCE, plus, and then we're directly accessing the commission rate and gross sales from the parent class, because at the moment we're allowed to do that since protected is how we declare the variables. So that's how we calculate the earnings. And then here is our toString function. And we'll see another way of doing these two functions as well, which will involve having the child class version called the parent class version of the function to do part of the work. But for now, what we're doing is we're just directly accessing all the variables from the parent class. So things like, for example, here we're accessing first name, field, social, gross sales, commission rate, and base salary. So that's allowed in this case because of the fact that everything was made protected in that parent class, in the commission employee class. So we can directly access those members. So a little bit of a difference in implementation, right? With toString and earnings. That's why we had to redefine those, right? If we didn't, then it would work the same way as it did in the commission employee, which means we wouldn't be able to correctly calculate things like the person's, their earnings, or display all 6 fields when we call the toString function. So we redefine those two, and we're seeing here at least one way in terms of how we can implement these two functions. Okay, so that's the logic that we have in the CPP file here. And so we saw that, again, a key thing here was that we do call that commission employee constructor. which we're doing in the member initializer list. And then we've seen how the other functions are working. So now we can look at the application program. And so here we're starting off by creating a BPCE object, right? So the child class object. And so we're putting in all 6 arguments here. So 5 of them come from the CE class, and then the last one is the last one here is the base salary. And so that's why that constructor, we wanted to have that, taking up to 6 arguments. And then here we just test some things out, right, by printing out different things. So this was the object here we called employee, and then we're just going through and printing out all the different information. And in the first block here, we're printing it out by individually calling the different, get functions one by one. But the other way that we can also print everything out is to call that toString function. Because remember, that's the function that builds that big string. And so the good thing about having that is it also gives us a way to print out everything without having to individually call, for example, all 6 functions like get first name, get last name, up to get base salary. So that's what we're doing here, is we're printing out the information again, but with the toString function. And that was one of the ones that we had to redefine in the child class because it was going to work differently compared to the base class. And then at the end here, we call the earnings function using that same object, right? That child class object. So just kind of, testing out the basic idea of first printing the object and then printing everything out. And then we change a couple of things like, for example, change the salary and then print the object out again. And then at the very end, print out the earnings. So just short application program to test out this child class a little bit. And one other thing also here is that in the application program, the only thing in terms of, aside from IOStream and IOManIP, the only class include file here we have is for the child class header file. And the idea is that since that header file, as we saw before, is already including, right? So we know that, in the base plus commission employee class, it already itself was including commission employee.h. So in terms of the application program, we only need to include the child class header file, right? We don't have to include them both, since this one is already, since the base plus commission employee header file is already including the commission employee header file. So that's why we only have the one there. And now we can run this, but again, just doing a little bit of tests here. But basically, we're just printing out everything, all 6 fields, a couple of different ways. And then at the very end, we also show the overall earnings. And so in this case, we're just creating the one object, right? So, and that's fine, right? We don't necessarily have to create, right? For example, in the application program, right? We don't necessarily have to create a parent class object before we can create a child class object, because we know that one way or another, when you create that child class object in its constructor, the first thing that's going to do is it's going to call the parent class constructor. So in that sense, it's perfectly fine here, in that we're not creating a CE class object at all, right? That's perfectly fine. So this application is still able to run just working off of this one object named employee, because we know, going back to the idea that is a relationship, that a BPC object is in fact itself also a commission employee object. So it's storing all that together as one big object in memory. And some of these concepts, right, we'll even expand further upon when we talk about polymorphism and what the implication of that is a relationship is. So polymorphism will directly build off of the foundation, right, that we're introducing right now. But that's why this application program is okay, even though we did not create a separate parent class object or CE class object. Okay, and so we'll go ahead and run this. And then that's the output here. So just a couple of different blocks. But the first block is printing out all the fields by calling the 6 separate get functions. And then after the first block, we changed the base salary to that new value of 1,000, and then we called the toString function to print it out. So the wording's a little bit differently because the toString function uses a little bit different wording compared to what the get function is doing with the cout statement that we had. But we're printing out the same 6 things again, except we changed the value of the base salary, and then the very last thing that we see there is the employee's earnings. But the key thing in making all this work was that it was important that we did in fact redefine earnings in toString, because they did need to have a different implementation compared to how they were working in the parent class, whereas the other functions did not need to be redefined. So that gives us an idea of the general idea of inheritance. So as we continue with this, we're going to take this to the next level, and literally, right, because we're going to have a third class and have three different levels of inheritance. So that's going to be the next step, right? So we'll recap some of the major points next week, and then we'll look at well, what if you had 3 levels? What would happen when you create the bottommost level object? Well, we'll look at the details of that next week, but the general idea is that if you think of it as level 1, level 2, level 3, well, the level 3 constructor is going to have to call the level 2 constructor, which in turn is going to have to call the level 1 constructor. So we'll see how inheritance will work when you start extending this to the next level, right? By literally having 3 or 4 or even more levels in your inheritance, and how that's going to work out. And then we'll also look at things like, well, how can you combine operator overloading in an inheritance context? We'll see how that's going to come as well. So that is still the case if we do a commission employee. Oh, in the app code, the include being in the BPCE. Still declare that. Yeah, oh, yeah. Yeah, because in terms of include, because like what we're used to doing, like when we've been working with multiple classes, when we haven't been doing inheritance, we've been doing like for example, include fuel gauge.h or include odometer. But the idea is that since one includes the other, that's still going to be fine. Mm-hmm. But you could also just separately include them as well. But yeah, in this case, just including the bottom level is fine since it includes the top level class. Mm-hmm. But yeah, so next week we'll extend on this. We'll look at 3 levels of inheritance. We'll look at operator overloading, how that's going to work out when you combine operator overloading with inheritance.